While safety and performance are the goals of Rust, for a new large project, I think that safety is the reason to use it, and performance is really a nice side benefit. So for this video, let's focus on safety, and we can start by giving some examples from around the industry. As we mentioned in the last video, Microsoft has publicly discussed major investments in Rust and the reasons behind their decision. Here's a video where a Microsoft employee named Ryan Levick shares that most of their vulnerabilities are memory safety issues, more than all other causes combined, every year. And while the Rust compiler removes these classes of errors, their code actually ran faster too. Well, that's comparing brand new clean Rust code to decades-old C++ code, apples to rotten oranges. It's still impressive. The Azure CTO, Mark Russinovich, famously tweeted that any new C or C++ project should instead be started in Rust. Note that his reason is safety and not performance. For anyone who's run a large systems project before, safety has to be the top reason. An Azure engineer, Taylor Thomas, gives us a clear example. Even though Go has a GC to get memory correct and a race checker to help with concurrency, they had a race condition in their Go code for over a year, which in Rust would be caught by the compiler and not have been able to hit dev, let alone test or production. Anyone who's spent time on a big systems project knows how long race conditions can take to find and fix when they're in production. Moving to Google and Android development, they've released large numbers of memory safety bugs in the past and much smaller numbers for new releases. The more amazing fact is why. As I mentioned earlier, for the newer version, about 20% of all new code is in Rust. And what I didn't mention then is that they have not yet found a single memory bug in any Rust code. That is, not after the Rust compiler is finished with it. It's not just companies. Government agencies have also started to notice the safety that Rust provides. The NSA, in their cybersecurity information sheet, advises people to move off of C++ to either garbage collecting languages or Rust. More recently, NIST identified Rust as a safer language. Their other options are mostly runtime checkers, and none of the alternatives are full programming languages like Rust, with compile time safety guarantees and also a large open source community of packages and modules. While all this safety is clearly important because it means fewer bugs and quicker initial development, it might be even more important that it lets you continue to maintain your code quickly and without fear. Have you ever seen a large code base of millions of lines of code where all of the prolific authors have left the project or the company and younger engineers who have barely seen the code start to add a new feature or fix a bug? They read up on the code that they're directly touching, but they don't know all the invariants and all the memory lifetimes and are bound to introduce new bugs. I've seen many products that had that problem. By putting most of the invariants and memory lifetimes into code instead of comments and having the compiler enforce them, it makes that new engineer's job much harder to get the code to compile, but means that most of those new bugs never make it to customers. A big win. This is one of the biggest reasons that I'm excited about Rust across the industry, and I found that others agree. In Discord's blog post about why they moved from Go to Rust, Jesse Howarth wrote that Rust makes it very easy to refactor code as product requirements change. Before I move on from discussing safety, I want to share quotes from two language creators. First, Graydon Hoare, the creator of Rust, on why it's more memory safe than Go. He's obviously biased, but I generally find him very honest and open in his writings on the internet. And either way, this quote is worth it. Go's memory model has no concept of isolating memory between coroutines or threads, nor of controlling mutability. Everything can always race on the same global mutable heap. It has only one kind of pointer, which can always be null, and all pointers in all coroutines are subject to a single global garbage collector. The other language creator is Bjorn Strostrup, the famous creator of C++, who had previously pointed out that using new C++ features combined with memory checkers can result in good memory safety. And recently, he responded to the NSA telling people to move off of C and C++ by pointing out that there are literally billions, with a B, lines of C++ code, and that applying newer technology to them would be much less expensive than rewriting it all in a new language. I think that he makes a good point, which is why no one is suggesting to rewrite all the old code. And in a world with less than 1 million Rust developers, it didn't even make much business sense to use it for new development. But given the popularity numbers and facts that we looked at earlier, it might be worth it to start any new systems project in Rust, which is both safe by design and popular. Having quoted the two language creators, let's move on to discuss the performance of Rust.